Well, I guess I'd have to start off by saying that for many years that's all I did, as I lectured quite a bit. And several years ago it became obvious that that wasn't enough. It wasn't promoting a deep learning. And so I've tried many different things over the years. Tried just having reading assignments beforehand, and that wasn't received very well. Tried having pre-quizzes, things like that. Students would do them, but I just wasn't seeing much difference in what they were taking away from the course. It's very clear to me that when students come prepared, we're able to engage in discussions at a much deeper level. Last semester, had made an interesting observation. About midway through the semester, I noticed that there was a group of students who just weren't doing very well at all. And they were bright students, and they just weren't getting it. And so decided to have kind of a recitation section. So every Monday night, and those who were interested, we'd get together and we'd just practice. We'd practice problems. And I saw their grades and their comprehension overall just increase dramatically. And I realized, I'm using my classroom time wrong. We need to be spending more time in class doing this, solving problems. And so this semester I tried something different. Tried to put all the lecture material online. So I have reading assignments on Canvas, have lectures, videotaped lectures online, which they watch before coming to class. They take a short quiz just to confirm that they've actually watched the material, that they kind of have a foundational understanding, and then we spend more time in class working problems, practicing, answering questions, and talking and trying to make connections. I didn't really know how to do it. In fact, I was terrified doing that way because I didn't know what are we going to actually do in class. When Dr. Mike Serva came from University of Delaware, he gave me kind of an idea on how that class time could be better used. So he taught us about making the problem-based learning problems, and we've been using those this semester, just a few. They do take some time to set up. The averages on the first 3 exams were considerably higher than I've ever seen them before. Typically I was happy if I could get a 75% average. Generally they were a lot lower than that. And this semester the averages were 83%, had a lot more in the 90s, 80s and 90s. Students are engaging and they're conversing more. And so all the evidences I have is that they really do seem to be taking a lot more out of the class. The first problem we did was it set up a scenario. It talked about a young mother who took her son into the doctor's office. He was complaining of some problems, and the doctor diagnosed it as sickle cell disease. So once you set up the scenario, typically the first question is to ask the students to consider what they know about the problem already, to kind of take an inventory. And then the second question is usually, what do you need to know in order to answer the underlying question? And then I ask them to get together in groups and kind of talk about these, pool their knowledge, pool what they know, and come up with 3 main ideas, 3 main research questions that they need to answer first before they can even start addressing the underlying problem. And the other neat thing about the problem-based learning is I'm able to, again, they're getting all the factual information that I want them to take away, which is preparing them for their MCATs and their GMATs and things like that. But now in class, since we're able to work on problems, I'm able to introduce whole new levels of things that I haven't been able to talk about before. I've just never had the time before. And so I was able to introduce them to a laboratory technique called microarray analysis, which makes use of these principles in a way that they probably had never thought of before. So in 265, in this class, I'd never talked about microarray analysis before. But by being able to introduce them to that idea, now they have a much deeper concept, not only the principles we've been talking about, but of some possibilities that are available for research, for genetic analysis. So we have the book learning, we have the thinking through, but then we have the actual application. And so that's very exciting to me, to see that they're able to do PCR and DNA sequencing and restriction digests when they get into the lab because they understand what's going on at the molecular level. they understand the concepts all that much better. I made a mistake on this last one, simple mistake. I wanted them to look at a DNA sequence and to extract some information out of it. I made the mistake of including the actual name of the gene. Found out some of the students spent most of their time learning about the gene, which really was not pertinent to the question. So you have to be very careful on the wording so that the students will take it in the direction where you want them to go. I had a student this last week who went to had a telephone interview for an internship with a USDA lab, and he said that it felt like just like your class, Dr. Gold. He says they were quizzing him on not just have you ever done PCR, do you know what PCR is, but what's going on in PCR, what's going on in Restriction Digest, how do you design PCR primers? And he said he felt very, very comfortable. He thinks he nailed it because he'd been through this process. So that was exciting to me. So far I've been extremely happy with the way that this semester has gone. I can see some things that need to be improved. I need to make those videos shorter and less boring, apparently. And I've gained a little more skill in putting those together. But I also want to have more of these problem-based learning type problems. I want to be able to delve deeper into some of these topics that we've just kind of been covering the surface on for so long.